Hey you guys, we're in chapter 12, section 3, and we're going to look at inscribed angles. Alright, so let's check out some vocabulary. Now, an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So below over here we see an inscribed angle. So here's an inscribed angle, angle C. We have its sides are made up of chords and the vertex is on the circle. Now an intercepted arc is an arc with endpoints on the sides of an inscribed angle and its other points inside the angle. So in our diagram, here's our intercepted arc. Its endpoints are on the sides of an inscribed angle and all of its other points are inside of the angle. Now to note here on the bottom, it says the measure of an inscribed angle is half the measure of its intercepted arc. And this is actually a theorem, and this theorem has a name. It's called the inscribed angle theorem. You don't need to know the name of this theorem, but just so you do, it's called the inscribed angle theorem. So basically it's saying in our picture up here, angle C is half of this measurement right here. So if this measurement was 40, then angle C would be 20. If this was 40, then this would be 20. Alright, so let's apply that inscribed angle theorem. Looking at our first example, it says what are the values of A and B? So what we have here for A, notice A is created, it's the intercepted arc of this inscribed angle. So the inscribed angle PQT. So using the theorem, if PQT is 60, then the measure of angle A is double that. So all we have to do is 60 times 2, so we get 120. 120 is the measure for A. Now we also want to find what B is equal to. B is right here. B is created right here by this inscribed angle, or B is this inscribed angle. And so we look at the intercepted arc. A is 120 plus this little arc right here is 30. If we add those together, we'll get the measurement for B. So 120 plus 30. So B is equal to 150 degrees. In this other example, we see we have circle O, and we want to find the measurement of angle A. So what you should realize is this line right here, this chord, is actually the diameter. And our inscribed angle A, its endpoints are at the diameter. So this measurement is half of a circle, and we know that a full circle is 360 degrees, so half of this circle is 180 degrees. That's our intercepted arc measurement. So if we want to find the measure for angle A, we just have to take half of 180, and we see that the measure of angle A is equal to 90 degrees. All right, so I want you to try. In this problem below, it says find the measure of angle A, measure of angle B, measure of angle C, and the measure of angle D. Now let's take a look at some corollaries regarding inscribed angles. This first one says two inscribed angles that intercept the same arc are congruent. So notice that this inscribed angle and then this inscribed angle, they have that same intercepted arc, and therefore their angles are congruent. So we're going to write arc right here. Looking at this second one, an angle inscribed in a semicircle is a right angle. And we saw this in our last example. So we have our diameter here, and here's half a circle or a semicircle, and that's 180. So then this inscribed angle would be 90. So inscribed in a semicircle. This last one says the opposite angles of a quadrilateral that's inscribed in a circle, well, those are supplementary. And that makes sense because we're saying opposite of each other. So angle B, here's its intercepted arc right here, and then angle D, its intercepted arc completes the circle basically. And since the angles themselves are half of the arc measurement, then half of 360 would be 180, causing them to be supplementary. All right, so let's check out these examples and let's use these corollaries. Our examples say, what is the measure of each numbered angle? So I want to find the measure of angle 1 right here. Well, we see that we've created this inscribed angle with these two chords. And these two chords, they end at the diameter. So we have this semicircle right here. Well, the semicircle, that's 180, so measure of angle 1, that's equal to 90. These other measurements here, 70 and 40, they're just here to throw us off. In our second example, we're trying to find the measure of angle 2. Measure of angle 2 is created by these two chords. Well, also created by those two chords, or not by those two chords, but the same arc is created by this chord and this chord. They share this arc. Therefore, these two angles are congruent to each other. Therefore, the measure of angle 2 is equal to 38. And that's 38 degrees and 90 degrees. All right, so now I want you to try. I want you to find the measure of each of these numbers. Measure of angle 1, measure of angle 3, measure of angle 2, and measure of angle 4. Use the corollaries. Now the inscribed angle theorem, it follows through even if your inscribed angle is formed by a chord and a tangent instead of two chords. So we have a chord and then we have a tangent, and that inscribed angle right there is still going to be equal to half of this arc that's created, the arc of BDC. Same thing over here, we have a chord and we have a tangent, then this angle right here is still half of this arc, half of that measurement. All right, so let's check out this example. It says in the diagram, we have a line SR that's tangent to the circle at Q. So here's our tangent line. It's going through this point Q. We have this chord here, PQ. It says if the measure of the arc PMQ, so talking about this arc right here, if that measurement is 212, so let's draw that on here. So from here to here, if that's 212, then what is the measure of angle PQR? So it's asking us for this angle measurement over here though. It wants to know what is that? Well, if we know that the arc measure of PMQ is 212, then I know that this angle measure right here is half of that. So I know 212, half of that is going to be 106. So I know this is 106. And then I know these two angles right here, they create this linear pair. They're on a straight line. So all I have to say is 180 minus 106, and I get 74 degrees, and that's equal to the measure of angle PQR. And there's my answer. I could have done this a different way too, just to point out, if you know this is 212 and a circle is 360, then you know this measurement over here is 148. And then take half of 148 and you would get 74. So you could do it that way too. Alright, so this is your last problem you try. In the diagram at the right, we have KJ is tangent to circle O. What are the values of X and what's the value of Y? So good luck. Take good notes. See you in class.